Hello everyone and welcome to the quick start guide video of Tejas OLT. I am Abhijit Aithal, your instructor for this video, currently working as a senior engineer in Tejas Networks. The objective of this video is to understand the basic bring up of the OLT from scratch and then proceed to create your first GPON connection. But before we step into creation of a GPON connection, we will understand the physical hardware components of the OLT. We will have a look at the fan tray units, the power supply unit and the front panel ports present on the OLT. Once you have understood the different hardware components on the OLT, we will log into the OLT and create our first management connection on the OLT. This management connection would be necessary to be able to log in remotely. Once you have established this remote connection, we will proceed with connection of the ONT to the OLT physically. This would involve understanding of various components of the GPON technology itself, which includes the OLT, the ONT, the splitter and the different kind of fibers that can be used for this connectivity. Once the different components have been physically connected, the ONT will get discovered on the OLT. We will then proceed to create a first GPON connection. For this video purpose, we will be creating a Wi-Fi or a VEEP GPON connection. I am excited to have you all in this session and look forward to your contribution to the learning community. To begin, I recommend you take some time and explore the course site and the prerequisites. If you have any questions regarding the curriculum, you can post them in the feedback forum so that our team can get back to you. For any technical difficulties with the course platform, visit the Learner Help Center. Good luck as you get started. Hope you enjoy the course. So today we'll be having a look at the front panel port of the TJ1400-1 OLT model, pizza box model. This variant, as you see, is a 8-PON port OLT model. We have another OLT variant model of the same product with 16-PON ports. Now let's have a look starting from the extreme right hand side of the different ports available on the OLT. The first port that you see over here is for the NMS purpose, is for management purpose. This one is used as the management port. This is the port number 1. The one below the management port is called as a local craft terminal port. This is used for local management as well. Now moving on to the further right, we see two ports over here. These are your Ethernet ports, port number 5 and port number 6, which are both used for 1 GG purposes. Now moving further, as I said earlier, we have 8 PON ports available over here, and on the first PON port you will see a pluggable module connected. Using an SCSC fiber, we will be connecting to this pluggable module and the ONT via these 8 PON ports. Moving further to the right, you see 4 Ethernet ports available here, which are ideally used for your uplink accesses. These ports, port number 1 and port number 3 are 10 GG ports, and port number 2 and port number 4 are 1 GG/10 GG ports. These are configurable ports. Moving further, we see 3 RJ45 ports available over here. The first RJ45 port above here is used for bits, that is your clocking purposes, and the second RJ45 port below is used for your TOD purposes. The third RJ45 cable that you see over here is used as in and out for alarm purposes, which can be used for external alarm indicators as well. The port below that is a USB port. Next, if you see, there is an audio jack available here, which is used as your diag port, which we can be connecting a laptop via this serial to audio jack connectors. So let us go ahead and have a look at the back of the device TJ1400 OLT pizza box model. Here we see there are 3 pluggable modules. The first one is a power supply unit, the second is a fan tray unit, and the third one is again a redundant power supply unit. The power supply unit that we are using today for the demonstration purpose is a DPU8 model. We will be connecting a DC power supply to this power supply unit to power on the device. So let us go ahead and power on the device. Now that the device is booting up, it will take some time for the OLT to be accessible. Once that is done, we will log into the device and proceed with our configurations. Hello everyone, so now let's start the demonstration on how to initialize a node from the default setting. So currently I have connected an RJ45 cable to the NMS port and to my laptop. Now on my laptop I'll be providing an IP in the subnet of 192.168.1.x subnet, that is I have provided here 1.222, and I'll just submit this. Now the OLT UI will be accessible with the IP of 192.168.1.254 with the port number of 20080. So this is the first login page that you will see. Now I'll be logging into the OLT using the username Tejas. Once I log in, this is the first screen that you will be seeing. You will see the options as restore from previously backed up configuration, initialize node parameter, and please install the software to proceed. So right now, because the node is in a factory default status, I'll start with the initialize node parameters. Here on this window, you can see various fields that can be provided by the users. That is name of the OLT, node configuration, router ID, Ethernet IP, and other fields. So I'll get into details about the router ID and Ethernet IP as we go on. So first we'll fill in the name. Now say if I want to provide this as my NEA as the name of the OLT. Now we see two IP addresses over here. When we talk about router ID, this IP address will be further used for our in-band management purpose. I'll explain in detail about in-band management purpose when we get to that section. The Ethernet IP address is the NMS port IP address that we are currently connected to. So currently we are using 192.168.1.254 address as such. So we will leave it as it is, as we do not require this currently. The TJ1400-1 port mode, you can see two different modes available over here. This basically will set your uplink ports, the 6 Ethernet port status, into different variations. The first status that you see is 4 into 10G and 2 into 1G model. The second is 2 into 10G and 4 into 1G model. So let us proceed with 4 into 10G and 2 into 1G model. Here in this demonstration, we will be going ahead with the in-band management purpose. So what I'll do is I'll configure the router ID over here as say 100.254. This IP will be later on used for the configuration of the management of the OLT. So once all this is done and you are satisfied with whatever configuration is to be submitted, we will click on submit. We will accept the changes. Once these changes have been submitted, the OLT will go for a cold reboot. This will take some time, so we will resume once the OLT is back up. Hello everyone. So once the initial basic parameters of the OLT has been set, the IP has been provided, the OLT will go for a reboot and the OLT will be reachable after some time. Once the OLT is reachable, we will again be able to access the OLT with the IP assigned on the NMS port. So the IP assigned initially on the Ethernet ID that we saw was 192.168.1.254. So we'll continue accessing the OLT via the NMS port. So we'll again log in using the username Tejas. Now the first important step that we need to do is we need to set the time zone. So we'll go to system time and click on set time zone, and we'll click on Pacific or any time zone that is desired. Once we submit this, the OLT will go for a warm restart for the configuration changes made to take into effect. Once the desired time zone has been set, we will then proceed to configure the time server, the NTP server. First, we'll enable NTP client using this Dropbox. You can see there are 5 different fields available for providing the NTP server IPs. So we'll go on and assign an NTP server available for us. And based on the requirement, we can set the synchronization interval between the NTP server. So here I'll set it as 16 seconds and I'll submit. So once this has been synchronized and the connection established, you will see the status change to status over here changing. Now let us proceed to the next mandatory step that needs to be done, that is configuring of the management service, that is the network interface. Under configuration, you'll click on DCN and you will see the option of network interface. So here you will see one interface has already been configured with the name of LAN 1.6. This is the NMS port that I was talking about, the first management interface available in the front panel of the OLT. You see the IP of 192.168.1.254 present over here, using which we are currently accessing the OLT. On this page, we will provision a new management VLAN interface, which we will be using for the in-band management purpose using one of the uplink interfaces. So we will proceed with creation of the management interface. We'll click on provision a new management interface. We'll click on the drop down box for the port option. You will see 6 uplink ports available with the nomenclature of Ethernet 1/1/1, 1/1/2, 1/1/3 till 1/1/6. So we'll proceed with the interface 1/1/1. We have to first decide on the management VLAN that we need to assign. Based on the deployment scenario that you have, here I'll go ahead and say I'll give my management VLAN as VLAN 2000. We can set the management VLAN priority as well. I leave it to the default 6 over here. The forwarding state will be set to the routing type. Broadcast interface disable or enable. For this demonstration, I will set the broadcast interface as enable. Now in the IP address field, once this broadcast interface has been set to enable, you will see these two new fields getting populated over here. So these two fields are user definable fields. So what is the IP address that we have to assign over here? This is the router ID that we set earlier on the node information page. This would be the OLT IP that you are using for in-band management. So in our case, we had provided 192.168.100.254. Net mask we will provide as 24 and we'll click on submit. Now this over here has created a management interface for us, which will be used for in-band management purpose using the uplink interface Ethernet 1/1/1. Once the network interface is created, you can leave the other fields default as it is and proceed to creating a static route. Static route would basically direct you towards the gateway interface. So we will proceed to add a new static route over here. Under the network interface option, we will select Ethernet 111 as this is our newly created network interface. In the destination network, we will provide the network as 0.0.0, which would mean any network, and the destination network address mask length as 0. Next hop would be the gateway address, which is connected over the port 111 directly from our OLT to the router. So here our OLT, we have given the IP of 192.168.100.254. So the gateway could be in the same subnet, say 192.168.100.1. This would be our gateway IP in that case. And we'll click on submit. Once we click on submit, we will get the prompt of successful creation of the static route. We can click on view static routes to see all the existing static routes that have been created. When the uplink has been connected on the interface 111, you will see the operational status of this static route as up. Welcome back everyone. So once the OLT has been initialized and the IP has been provided to the OLT and other necessary fields in the initialization page was populated by the user, the OLT will go for a cold reboot, and after some time the OLT will be accessible. So we'll again log into the OLT UI using the username Tejas. Now the first important step that we need to take care of is setting of the time zone. So we will click on system time, we will click on set time zone and change the time zone based on the requirement. So here in this video, for example, I'll be setting the time zone as Pacific time. Rest of the fields I'll leave it default as it is and I'll submit this. Once we submit the time zone, the OLT will prompt us to provide a reboot to the OLT. So we will go to maintenance and system restart option and I'll provide a cold restart to the system. The OLT will be reachable after some time, so we'll proceed with the next topic once the OLT is reachable. So once the network interface has been configured and the static route has been defined, we can proceed with the physical connectivity of the ONT and then the GPON service creation. But before I proceed to the ONT connection, I'll just walk you through the interfaces that are available on the OLT. We'll first click on node slot view and click on the 1401 8P FD card over here, and we'll proceed to click on GPON ports over here. This over here showcases the 8 PON ports available on the OLT. We can proceed to click on one of the desired PON ports where we want to connect the ONT to. Once we click this, we can see that the admin state of this PON port is deactivated. So I desire to connect the ONT on this specific PON port, so I'll go ahead and I'll activate this PON port. I'll report the changes to the OLT. Once this is done, we'll get the confirmation message as successful reported. So for every desired PON port where we need to connect an ONT, we can do the same thing by clicking on the required PON port and making the PON port as admin up. Now this was for the 8 PON ports that we have. Now let's have a look at the uplink ports of the OLT. So for that purpose, we will click on L2 services, service switch 1 and port configuration. Here you see there are 6 Ethernet ports available as shown earlier. Now if I have configured my DCN, my management interface, the network interface that we saw right now on Ethernet interface 1/1/1, and I wish to use this interface for my data traffic as well and management. So I'll go ahead and click on edit physical parameters of interface 1/1/1. I'll change the admin status to up and I'll submit the changes. So that is all for the Ethernet interfaces. Any other Ethernet interface that you need to change and you want to make the link up, you can just change the admin status by clicking on the edit physical parameters. So now we'll proceed with the physical connectivity of the OLT and the ONT. So now let us have a quick walkthrough over the physical connectivity of the OLT and the ONT. But before we proceed with that, I'll give you a brief description on the components that would be needed for this connectivity. Over here, we have a TJ1400-1 pizza box OLT model of Tejas. Here we have TJ1400-N ONT of Tejas, and here we have a 2:4 splitter. The other components that would be required is an SC APC fiber with a green and a blue end, and an SC APC APC fiber with both green ends, and a 10 dB attenuator. So now let us proceed with the physical connectivity. This is the 10 dB attenuator that we have over here, which I will be plugging in into the PON port SFP module. Now using the SC APC fiber, I will be connecting the SC end, the blue head end, on the PON port, and the green head end of the SC APC fiber into the splitter in port. Now using the second APC fiber, I'll be connecting the out port of the 2:4 splitter and the other end of the APC fiber to the ONT. This completes our physical connection between the OLT and the ONT. Hello everyone. Now that we have seen the physical connectivity between the OLT and ONT, let us log into the OLT and see the current status of the discovered ONT. We will have to click on the node slot view option and select the TJ1400-1 8P card over here. Under this, we can see the option GPON ports. We'll click on the option of GPON ports and we'll see all the available PON ports. In this page, we see that the ONT that we had connected physically on PON port number 1 has been discovered with the ONU ID of ONT1111. On this page, we can also see other information such as the physical status of the ONT. Over here, it is activated, the serial number of the ONT, the model and the make of the ONT, and the conflict state of the ONT. Now this conflict state basically will be useful in case of a duplicate ONT connection, and if there is a duplicate ONT current present over here, it will show us the original ONT where it is located on this specific OLT. Now that we have seen the ONT is activated and present on the OLT, let us proceed with our first GPON connection. So what we'll do is we'll connect to our ONT and create a WAN connection first. So I have connected to the ONT Wi-Fi interface over here. I'll log into my ONT using the default IP 192.168.1.1. On this page, I'll click on Advanced Setup and Layer 2 Interface. This basically is where we add a VEEP interface which will be necessary for creating the WAN connection on the ONT. We will apply and save. This has now in turn created a VEEP interface on our ONT. Now we can see the second option over here, which is the WAN service. We'll go ahead and click on WAN service. Right now, as we do not have any WAN connection present, this will not be populated. We will click on Add WAN service. We will select the VEEP interface that we just created and click on Next. Over here you can see three different options that we can select. The first is PPPoE. Our WAN connection can be a PPPoE connection wherein we'll have to provide respective server details in the next pages. Let's go ahead and see how that is done. Over here I'll give a service name, say test_01, and the priority and the VLAN of the service that I want, and the VLAN TP ID. The options that you see over here, let us proceed with 8100 for the demonstration purpose. And I'll leave the option as IPv4 only and click on Next. On this page, we have to provide the PPPoE username, password, and the service name. Once we do that, we can click on Next. Let's go ahead with say test, and the service name also as test. We can select the authentication based on our requirement. I'll leave it to auto for this demonstration purpose. In this page, you don't have to make any changes. You just have to click on Next. Here, you have to give the primary and the secondary DNS server IP information. For my lab information, I'll proceed with my lab DNS info. This being my primary and this being my secondary DNS server information. This is the last page which gives us the overview of the configuration that we have done so far. Once this is done, we can click on Apply. As you can see, we have created a PPPoE connection over here with the name of test1 and VLAN ID 100. For the entire demonstration purpose, I'll go ahead and remove this and just create a IPoE connection. So I have deleted that connection. Let us go ahead and add a new WAN interface using the same VEEP connection that we had. I'll click on Next. I'll select IPoE, IP over Ethernet, give a name to the service, the WAN connection, priority 0 and VLAN 100, TPID 8100, and I'll click on Next. Over here, there are two things that can be done. I can create the WAN interface with IPoE using DHCP option or using a static IP. For the demonstration purpose, let us go ahead and create the WAN interface with a static IP. See, if I give the IP 10.10.10.10, subnet mask as 255.255.0 and the gateway as 10.10.10.1. I'll click on Next. I will enable NAT. This field you have to enable. Then click on Next. This field again you don't have to do anything and just click on Next. This will basically prompt you to provide the DNS IP as we have not enabled DHCP server. So we have to provide the DNS IP statically. Over here, I'll provide the DNS IP as 192.168.0.202, 192.168.0.204. Click on Next, Again, I get the overview summary of the WAN connection that I was creating so far. I can click on apply. So this now has created a IPOE connection with static IP address and VLAN 100. Now that we have created a WAN connection on the ONT, let us go back to the OLT and create a GPON connection on the OLT. In the OLT, we can see the option of GPON. We'll click on GPON. We'll click on service profile. This service profile is basically a template that will be used for a GPON connection. We'll click on add service profile. Over here you can see many fields that need to be populated by the user. Here I'll give a profile name, say test_01. OLT card basically provides you with all the cards that are available with PON ports. The model that we are using right now is a pizza box model with a single card. So there will be only a single card available over here. Service type, as we are creating a Wi-Fi, we have created a WAN interface already on the ONT. I'll go ahead and select Wi-Fi. ONT tag type, input to the ONT, I have provided a VLAN, so I'll go ahead and select a single tag. And my deployment type is single. Over here we can see three fields for different bandwidth assignment. The first being fixed bandwidth, second being assured bandwidth, third being the maximum bandwidth. These three fields basically dictate the kind of TCON that you want to define for the GPON connection. For our demonstration purpose, I'll go ahead and make it a best effort service and provide a 1 gig bandwidth as best effort. The VLAN that we have created on the ONT was VLAN 100, so I'll go ahead and select VLAN 100 and click on submit. The confirmation page again asking us for the verification of all the data over here. We can just click on yes. We can see the service profile has been successfully created. Now we'll use this service profile to actually create a GPON connection from the ONT to the OLT. We'll click on the option of connections over here. As of now, you can see there are no GPON connections currently present. We'll click on add new connection. We'll provide a connection name, service type as Wi-Fi. Now under the PON port, we can see all the 8 PON ports available over here. We can select any PON port that we wish for, but if you see, we have selected PON port 112, but there is no ONT discovered on this PON port, so this field is not getting populated. So we'll go to the PON port 111 where we have actually connected the ONT. You can see this field gets populated with the ONT 1111 which has been connected. The next option that we need to select is the service profile. We'll go ahead and select the service profile test01 that we have just created for VLAN 100 Wi-Fi connection with a best effort service. Now once we select the service profile, all the other fields get populated by itself using the template that we have created. We can click on submit and confirm the submission. Once the GPON connection gets created, we will get a confirmation of the GPON service that has been successfully completed. We can see successfully reported add connection. We can go back to connections and verify that the GPON connection has been created. Once we have successfully created the GPON connection, we can see the GPON connection name, the type of connection that has been created, the ONT on which the connection is being dropped, and the VLAN ID and other further details on the specific page. We can click on the connection and see detailed information as to VLAN and the bandwidth that has been assigned and the service profile that is being used for the creation of this GPON connection. The next step that we need to do after this GPON connection is to deliver this GPON connection on our uplink interface. So how do we do that? We'll go ahead and click on L2 services, service switch 1, and click on service provisioning and click on ELAN services. This basically is an L2 service that will deliver our GPON connection from our PON ports to the uplink port. If we go to our port configuration, and we can see that we had admin up the first port over which we have created the network interface, and also we'll be delivering the same service GPON connection that we created on this specific interface. If we go down a bit, we see 8 other ports that are present over here. These 8 ports are logical representation for all the PON ports that are physically present. These BP, that are backplane Ethernet ports, are one-to-one mapped to the PON ports. If we see the BP11201, this is basically mapped to the PON port number 1. So for our L2 service creation, we will be using the Ethernet port 111 and the BP port 11201. This is nothing but a logical interface that is currently present, just used to deliver the service from the PON port to the uplink interface. Now let us go back to the ELAN service creation and add new ELAN service. This basically asks you for the service name. Let us say again test_01 and click on create. Now you'll go back to the service. Right now this service is an empty bucket with no interfaces added to this service. The next step would be to add the BP, the PON port and the uplink Ethernet port to this service so that the service can be delivered from the PON port to the uplink Ethernet interface. Let's add new flow point. Over here we have to first create a flow point template. You see the option over here. We can click create flow point template from here, or we can also go to the field that is present over here under service provisioning, the flow point templates. Let's go via this path. I've clicked on flow point templates over here and I'm provisioning a new flow point. Now that we have created a GPON connection with VLAN 100, we would want to deliver the same service with VLAN 100 to our uplink interface. So let us create a flow point template with VLAN 100, flow point type as CVLAN, and VLAN range being VLAN 100. This basically creates our flow point template. It is a template, a VLAN template that can be used for service creation. Let's see the flow point template that we have created currently. Yes, it is currently present over here. So let us go back to ELAN service creation. Click on the bucket that we already created, the test01 service, and add a new flow point. Over here, our ports are currently in .1 queue mode, and thus we see all our ports being populated over here. So as I want to add the uplink port, Ethernet port 111 to this service so that it can be delivered to the next node or the next router, and the flow point template has already been populated over here, as that is the only flow point template available in our chassis. I'll select this and click on create and confirm the submission. You go back to the service and we can see the interface has been successfully added to this service. Now we need to add the logical port representing the PON port number 1 to this service as well. So the logical port that we saw representing PON port number 1 is backplane Ethernet port 11201. Again, we'll select the flow point template as VLAN 100 and click on submit. So now we have seen the end-to-end creation of a GPON connection, starting from WAN connection creation on the ONT, then the GPON connection on our OLT, and then delivering of that GPON connection to our uplink interface, Ethernet interface 1/1/1. Let us just briefly go back to our ONT and see the status of the GPON connection on the ONT. This being the first page, we can click on WAN info and we can see the current status being connected.
So now you have understood the basic breakup of the OLT and successfully created your first GPON connection. See you in the next video and thank you for watching.